So, we are continuing the discussion on the fuel injection system, and in this part what we are going to do is we are going to understand how the fuel pump works. So, we have seen that the fuel injection system has the fuel pump which is supposed to give the metered fuel to the diesel engine, and then you have the nozzle which is responsible for the atomization of the diesel fuel into small liquid droplets which eventually burn. So, in this lecture we will see how the fuel pump of a typical diesel engine operates. It is a very critical component of the diesel engine, the success of the diesel engine, for example. So, you should appreciate the fact that the diesel fuel has to be injected in a liquid form at high pressure. The piston has already compressed the air, and as you will recall that it is an excess air engine. So, there is the equivalence ratio is very lean, and the piston has already compressed this air, and now a certain amount of fuel depending on the power requirement of the engine has to be delivered in a given time, in a finite time at high pressure inside this combustion chamber. So, how does it happen? How does the metering takes place, and how does the high pressure is created? How the high pressure is created is what we are going to see in this lecture. So, coming to the fuel injection system, the diesel fuel pump operation. Now, if you see the history of the development of this diesel fuel, you see two types of injection systems. One is an air injection system and one is a solid injection system. So, by solid we mean to say that it is like a misnomer, but in a solid injection system the liquid fuel is injected directly into the cylinder, and most of the modern let us say automobiles or diesel engines, they operate with solid injection. In the earlier system, when the development was starting, or in the early phase of the development of these type of injection systems, the fuel was forced into the cylinder with the help of compressed air. Now, so essentially the engine had to create let us say compressed air system, which in any case all the automobiles even today do. But then the efficiency of this system in terms of giving the proper atomization and the proper control of the atomization process is not very good in the air injection system. The system is also bulky, and most of it almost it is obsolete now. So, we will not discuss air injection system. In the air injection system, the compressed air was used, and with the help of this compressed air the fuel was forced into the cylinder. Now, of course, we need to carry a bulky air compressor system, and as you know the air pressure which is required for injection is pretty high, and so therefore, for stationary engines it was simple, or it was relatively simple to make a compressed air or a compressor system along with the stationary engine, but for mobile engine it became more and more difficult to give such high pressure let us say atomized fuel with the help of air in this system. So, this is now obsolete. So, what we are going to study is the solid injection system, which essentially is that liquid fuel is injected directly into the cylinder. There is no air assistance, so to say. The cylinder is already pressurized because of the compression stroke. Now, there are a couple of 3-4 different types of let us say solid injection systems which are available. For example, you may have an individual pump and nozzle. That means, if you have let us say multi-cylinder engine, that each cylinder will have its own pump and a nozzle, of course, but the pumps are also similar. You can also have a unit injection system. We will discuss in more detail what is a unit injection system. Then you can have a common rail system, and then you can also have a common pump with a distributor system. So, we will after we understand how an individual pump works, we will see the injection systems also in detail in the subsequent lectures. So, right now we are focusing on solid injection system. So, now in a solid injection system you essentially require a fuel pump. Now, this is a pump, this is a cross section of the pump, this is also a cut section which shows the details of the pump. Now, it is a very interesting piece of mechanical machinery. The most important part or element of this fuel, of course, as you can see, it is a bulky component. You need to create a lot of pressure ranging typically from 30 to 70 bars, and this high pressure is created by what is called as a plunger here. You can see a plunger okay, which this plunger with a retainer spring here, this plunger is pushed up and down. So now this is like a standard piston pump, okay, like a piston pump, you need to push this plunger up and down. Naturally there will be an acceleration phase, there will be a push of the fuel to the outlet here. This is the outlet from where the fuel will go. I had in my earlier lecture I had also shown you a nozzle. So the nozzle is actually connected to the outlet of this pump. So the inlet of the nozzle is connected to the outlet of this pump. So there is a plunger here. Now this plunger has to perform two things. One is that it has to push liquid, that is it has to create the required high pressure by which the fuel will be pushed from this outlet to the fuel nozzle, okay. That is the first thing. The second thing this plunger has to do is to also meter the fuel. That means depending on the power requirement of the engine, we should have the exact amount of fuel which should go. So sometimes if the power is more, then the delivery of the fuel should be large, and when the power requirement is low, then the delivery of this fuel should be low. That means now imagine the fuel is coming from a primary pump, so that a certain amount of minimum pressure is maintained at the inlet here, okay, and there is something called as a spill port. So there is an inlet port and there is a spill port, okay, and there is a delivery port. So there are essentially 3 ports for this particular pump. Now as you can also see that this helix is actually attached to a gear, to a circular gear here, which is attached to a rack and pinion mechanism. So if you push and pull this rack and pinion number 6, okay, if you move this rack and pinion, this helix can turn. So there are essentially 2 things which are happening. You can see here at the back, this is the rod which is the rack on which this pinion, you can see this pinion here. So this pinion is mounted, and when you turn the pinion, this particular plunger, which has a very special geometry here, we will discuss more about this geometry in the next slide. So this geometry you can see here, there is a helix which is cut here, and this plunger can go up and down, and during this stroke, okay, when it is going up and down, so it will go up and down when you push it from here, okay. And how do you push it? You require a camshaft. Now why do you require a camshaft? Because there has to be a certain timing at which you would like to do this particular operation. As you will recall, in a petrol engine you have a spark plug, so the electrical connection to the spark can be controlled and you can control the spark timing. Now here the timing is controlled by a camshaft mechanism, which is there is a cam which pushes this, okay. So I will show you also a video subsequently which will show you this pump in operation. You can also see that on the internet, for example, but I will also give you a video where you can actually see. So there are 2 things happening in this pump. One is the plunger is going up and down, that is the first thing, okay, because of which a certain amount of fuel is getting delivered. Now how do you control the delivery? How much fuel has to go outside? This is delivered, or this is controlled by the rack and pinion. That means this particular plunger can go a reciprocating motion, and it can also undertake a rotary motion as it is going up and down. So that means during its operation, during its forward stroke and backward stroke, you can also turn this plunger. Now how does the turning help? Okay, so you can see the inlet port which is coming from the primary pump, there is a ferrule here, and there is also an online filter, after which, because we need a very filtered fuel here, I will tell you the reasons why you need that. From here the fuel will come and there will be certain pressure which will be maintained here, okay, at this point. Now this pressure will fill up this gap, okay, and if you push this plunger up, it will start delivering. But you can also turn the plunger, okay. Now how does that turning help? Because remember that we want to not only push the fuel inside the diesel engine, you also want to meter it. That means how much of this fuel which has been contained in this let us say cylinder, okay, how much of this fuel is actually delivered. Do you want the entire delivery of this fuel, that will give you maximum power, or do you want to give only partial, let us say 15% of this chamber volume should be delivered to the engine? That also needs to be controlled with this pump. Mind you, In a typical pump, because the pressure which will be created here will be of the order of 50 bars, let us say, or 50 to 70 bars, depending on the size of the engine. Okay. No amount of, as you can see, this is a piston actually, it is like a piston, it is a piston cylinder mechanism here. Now in a typical piston cylinder mechanism, you can only have, you cannot use any, because you want to seal this chamber, because as the push is happening, you have to do work done, you have to do work on this piston, and this particular, let us say, this particular piston, you cannot tolerate any back pressure or back leakages from this particular cylinder. So mind you, at this high pressures you cannot use any deformable, let us say, deformable gaskets. Okay, you can't use, for example, rubber or Buna rubber or natural rubber or neoprene, those type of gaskets you cannot use here. You cannot use a deformable type of a gasket to seal the high pressure which is created here, because you are creating almost 50, 60, 70 bars in this small volume here by pushing this piston up. Naturally this spring has to be strong enough. The entire let us say design has to be strong, so that it let us say retains this pressure effectively within this small pump, within this control volume, and there should not be any leakages in this pump. So one of the interesting features of this pump is that it has a metal to metal contact between this cylinder liner and this piston plunger. Okay, and naturally the tolerance level of this is extremely high, and there are very few companies in the world actually who manufacture such type of specialized pumps. Okay, because you have to create this pressure and a leak tight mechanism just by metal to metal contact. That means the finishing of this cylinder and the finishing of this liner should be done in such a manner that you can get continuous operation of this pump for thousands of cycles. In fact, mind you, there is also a coefficient of thermal expansion which comes into picture. The fuel is usually heated up to maintain the viscosity and the amount of work which is required and the spray dynamics. So it comes at a certain fixed temperature at this location, and therefore here the pressure should be high enough and the temperature should be right, the viscosity should be right, and also there should not be any foreign particles, because there is a metal to metal contact between this plunger and this outside liner, and no amount of fuel should leak from here, because if the fuel starts leaking from this side, that means the pump will not be able to create the high pressure which is required. So you have the inlet port, you have the outlet port, and you have a spill port, and then you have a rack and pinion mechanism to turn this plunger as it is going up and down. So now why does it happen and how does it work? So let us try to see that. So in this, the helix operation or the plunger helix operation is explained in this slide. As you can see, you have there is a helix which is cut. So now let us first see the helix. So you can see there is a very special helix which is cut here, and this is the diagram of that helix, and this is a single monolith metal piece out of which this particular geometry has been cut, and you can see that there is a sort of a helical structure which is cut on this particular plunger. Okay. Now what does this helix do? Okay, you have the inlet port, you have the outlet port, and you have the spill port. Okay. So far as the plunger is below this, the inlet port is directly connected to the outlet or the spill port, and you cannot deliver anything up, because there is also a spring at the top which you can see here. Okay, you can see this retainer spring here on the top also. So this maintains a certain opening pressure. So unless the pressure is higher than a minimum, this spring will never open and you will never be able to deliver. And this pressure at the inlet is not sufficient to push it up. Naturally you need the push of the plunger to get that thing going. Okay. So there is a retainer spring on the top, and therefore you can see here that right now nothing can go on the outside, and the inlet fuel comes and it is directly connected to the spill port. So the spill port goes back to the fuel tank, let us say. So there is no delivery. Now what happens is that during the piston stroke, this piston uncovers it covers the inlet port, and it also covers the spill port, so that pressure is generated here and you start getting delivery of the fuel. Okay. Now as the piston goes up, you can see that because of this helix, a time will come in the stroke when this helix will open up this particular port here, the spill port. So, as soon as that happens, then this spill port gets connected to the inlet port. Okay. So, that means now the pressure in this chamber will immediately fall, because this on the top you can see here, you can see this top portion here. From this top portion, this particular fuel gets now connected to the spill port. So, essentially what happens is that the stroke length, okay, the stroke length is actually equal to this particular length which is uncovering the spill port. So, if you turn this helix, okay, then the stroke length will become only this. So, depending on what is the location of this helix with respect to the spill port, okay, you can create the actual effective stroke as starting from here, and you can progressively increase the stroke length as the helix is turning. So, if you need more fuel, let us say, okay, if you need more fuel, then naturally this longer portion of the helix, should come in front of the spill port. If you require less amount of fuel, then this small portion of the fuel or small portion of the helix should come in front of the spill port. So, let us try to understand that from this diagram, which is more clearer. So, now here you can see this is the outlet port, this is the suction or the inlet port, and there is a spill port. Okay. Now, at this location, certain amount of fuel has been trapped inside the chamber, and as the piston is moving up, okay, it is delivering to the injector. It is delivering through this spring, it is delivering to the, or a non-return valve and a spring, it is delivering it to the engine. Okay. Now as the plunger starts going up, you can see this is a helix, and a certain time will come when the stroke length will be completed, and you will get the spill port, which will now come in contact with the inlet suction port. So, as soon as that happens, the pressure here is low, and therefore, this extra diesel actually goes out of the spill port and goes back to the fuel tank. Now, imagine that this has been turned. Okay. So, now so you see the helix here. Now, in this portion the helix is not turned, so you have a larger stroke. If the helix get turned in a certain direction, then you can get only a small portion. So, the stroke length has now been reduced. Okay. So, here you see the reduced stroke length. So, now imagine a situation, now who is turning this plunger? That is also important to understand, that who is actually moving this. So, now this is moved depending on the feedback which we are getting from the governor. So, the engine governor who maintains a specific power requirement to the engine. So, as the engine wants more and more power, you have to turn this so that the effective stroke of the plunger increases. Okay. So, what does that happen? How does that happen? The governor will sense the power requirement, and depending on how much fuel is required by the engine, because if the power starts increasing, for example, the RPM of the engine will start going down, and as soon as the RPM goes down, the centrifugal force which is created by the governor starts going down, and it senses that we require more fuel now because the power requirement is going up. Okay. It can be a generator, for example, or it can be a vehicle which is climbing upstairs or in an inclined plane up in the upward direction. So, the governor will actually move this. So, when I will show you the video of how exactly it works, you will appreciate this particular rack is connected to the governor, and as the piston is going up and down, okay, the piston is continuously going up and down, this plunger is going up and down with the camshaft which is down below here, the cam is pushing and creating the force necessary for creating a high pressure here. So, as this is happening, your governor is sensing the power requirement, and it is turning this rack, which is turning the pinion, which is turning the helix. So, in this way, which portion of this particular stroke comes in front of the spill port is now getting controlled by the governor by turning this piston along its axis. So, it is reciprocating because of the camshaft movement, and it is rotating because of the governor movement, and because of which how much amount of fuel actually goes in the engine is being controlled. Okay. So, here you see one more let us say a closed diagram of this plunger, and here you see how exactly the pinion is attached to the rack, and this rack is moving, and depending on where the plunger is, you can control the effective stroke. Okay. So, if the helix is turned in this direction, then your effective stroke becomes longer, and if the helix is turned in the other direction, your effective stroke becomes let us say smaller. And what is this effective stroke? It means the point at which this will, as it is going up, it will uncover this portion, and your main pressure in the control volume, the high pressure zone will now get connected to, or get bypassed, or it gets short circuited to the spill port, and from where the excess fuel can go back to the fuel tank. Okay. And whatever the delivery has occurred, that is what exactly is required by the engine. So, the governor senses the power, the governor turns this rack or pushes this rack in forward or aft direction. This rack essentially turns the wheel which is connected here. This wheel, the pinion is connected to the plunger, and this plunger will turn, and in this manner the movement of the toothed control rod turns the pump plunger to vary the amount of fuel which has been injected. So, this is how a typical fuel pump works. Okay. And you have to understand that it is a very beautiful piece of mechanical machinery in which you are not only able to create high pressure, let us say in the liquid diesel, which is required for the proper atomization of the spray. You are also able to control the amount of fuel during operation. That means the piston is going up and down, the plunger is going up and down, and it is also able to turn. Okay. So, it has two motions, one is a reciprocating motion up and down by the camshaft, and the small turning motion which occurs because of the rack and pinion, which is being controlled by the governor. And this special helix which is cut on that particular plunger, it controls the effective stroke of that plunger or effective stroke of the fuel pump. So, in the next lectures we will also see what is unit injection, what is a distributor system, for example. We will also try to see a video in which you actually see a generator set which is running, in which you can see the fuel pump into operation, and how the governor is controlling the fuel pump. So, we will complete the discussion in another 2 or 3 lectures on